In this last section for Chapter 3, we're going to discuss two other methods of client-server communication. The first one is known as RPC, or Remote Procedure Calls. So a remote procedure call is a method that really abstracts procedure calls between processes on networked systems. It does use ports for service differentiation, so that may be something that may ring a bell from the sockets communication that we were having. Um, Key things about remote procedure calls. They are similar to inter-process communication. The big distinction being, however, that the procedure is being called on a remote system. This is not on the same system. Um, the way they get implemented is, there are stubs, which are client-side proxies for the actual procedure on the server itself. Right, so these stubs are quite relevant when it comes to the actual procedure executing on the server. Additionally, the client-side stub locates the server and it marshals the parameter. And parameter marshaling is the whole process of really packaging the parameters into a form that can be transmitted over the network. The server-side stub receives this message, unpacks the marshal parameters, and performs the procedure on the server. On Windows, the stub code is compiled from a specification written in the Microsoft Interface Definition Language, MIDL. Okay, let's continue. There are a few other important attributes when it comes to remote procedure calls. The first one is data representation. So you all are likely familiar from computer architecture about the differences between the big endian and the little endian architecture when it comes to CPUs. And really, there is no preferred way, so to say. It's not to say that big endian is better than little endian. In the end, if we want to represent, let's say, a 32-bit integer, one of the ways is what will be chosen somewhat arbitrarily, right? And what we're doing here is deciding how to store the most significant first. Or you do a most significant bit, right? So does the MSB first go first, or the most significant bit go last in terms of the representation of a given data type, such as an integer? Now, what we do in this scenario with RPCs, in order to not have to contend with these issues of big endian and little endian architectural implementations, is really use data representation methodologies known as XDL, right? So it's an XDL format, external data representation, and that really obfuscates, or it adds a layer of indirection in terms of having to deal with big endian or little endian. Additionally, remote communication has more failure scenarios than local. That's an important point to the extent that messages can be delivered exactly once rather than at most once. So an important element that is, historically also, in my experience when I've worked with RPC implementations, that definitely becomes an issue, right? So failure scenarios are more common, certainly when it comes to remote communication. And then finally, the OS typically provides a rendezvous or a matchmaker service to connect client and server. Okay, so let's look at a workflow of the execution of an RPC, of a remote procedure call. So let's start with the client. The user calls the kernel to send RPC message to procedure X. The next step there, still on the client side, the kernel sends the message to the matchmaker to find a port number. On the server side, the matchmaker receives the message, looks up the answer. The matchmaker replies to the client with port P. Hey, listen, go ahead and send the message to port P. The client gets that message. The kernel places port P in user RPC message, Further, the client then actually sends the RPC, the remote procedure call. On the server side, the daemon listening to port P receives the message. The daemon processes the request and processes essentially the output to be sent out. And finally, the kernel on the client side receives the reply and passes it up to the user. So pretty nice, well-defined workflow here. Okay, so that was remote procedure calls. Our last topic here in the context of client-server communication methods is pipes. So pipes are a mechanism that are fairly simple to implement. They've been around since the early days from an implementation perspective, certainly in Unix. They've been around for a long time, since the early days of Unix. They are effectively act as a conduit, allowing two processes to communicate, right? So a very simple way to do this. There are a few issues that need to be considered in the implementation of pipes. So first, is my communication between these two processes going to be unidirectional or bidirectional? The second issue is if there is two-way communication, is it going to be half duplex or full duplex? Am I going to allow both parties to talk at the same time? Third, must there exist a relationship, a parent-child relationship between the communicating processes? And fourth, can the pipes be used over a network? Okay. There are two different types of pipes when we are generally talking about pipes. There are ordinary pipes and named pipes. The ordinary pipes cannot be accessed from outside the process that created those pipes. And typically a parent process creates a pipe and uses it to communicate with a child process that it created. Whereas with named pipes, they can really be accessed without this hierarchical parent-child relationship. Okay, so let's look a little bit further at ordinary pipes. They allow communication in standard producer-consumer style. The producer writes to one end, the right end of the pipe. The consumer reads from the other end, which is the read end of the pipe. The ordinary pipes are therefore unidirectional. They do require a parent-child relationship between communicating processes. In Windows, by the way, these are called anonymous pipes, and there are code samples right in the text. We will do a quick demo right at the end here to illustrate some of these examples. And then finally, with named pipes, they're definitely more powerful than ordinary pipes. Communication is bidirectional. There's no need for this parent-child hierarchical relationship. And then several processes can use the named pipe for communication. And the nice thing with named pipes is they are available both on Unix and Windows systems. And that sums up Chapter 3. We're just going to do a quick demo of pipes and then call it a wrap for Chapter 3. Thank you.